Hello everyone, this is Sai Sri and welcome back to my channel. In the previous video, we have seen what is Cartesian coordinate system and what is the use of coordinate system, how we represent a differential element coordinate system. That means there is a small change in the x, y, z and the axis. What is the result of the position of the point, how it is going to be changed, and the surface, differential surface. So these are all the things are very useful in the EMTL. In further doing the sums, whenever we do some other sums, they are very useful. So in order to do those sums, we have to learn this coordinate system. So if you see the cylindrical coordinates, Cartesian coordinate system, there we have the three axes. They are the x, the y and the z. So these are the three coordinate systems which we have in the Cartesian coordinate system. But coming to the cylindrical coordinate system, here we have the three planes. If you take a cylinder, we have the top part and the bottom part and the curved surface part. So coming to the curved surface part, the curved surface part is phi. And the top part we can find the radius. So the other thing is radius. And the other parameter is the z-axis as we have in the Cartesian plane. So these are the three that present in the cylindrical coordinate system. So this is the basic difference between the Cartesian coordinate system and the cylindrical coordinate system. So if you see here, the circular cylindrical system coordinate system is a three-dimensional version of polar coordinate system. So here we have the three diagrams. Let us understand them with this. So the first point represent the surface used are plane of constant z which is parallel to the xy plane. Here I will show the animation to it so that you can understand them better. And the second one is a cylinder of radius r with z axis as the axis of the cylinder. And third one, a off plane perpendicular to xy plane and at an angle phi with respect to the xz plane. Don't be confused. I will show the animation to the three cases so that you can understand the cylindrical coordinate system in a better way. So let us see. First of all, see what are the ranges of the variables, and then you can see the three parameters, that is r is constant, phi is constant, and the other one z is constant. So with the animation, what I am going to show here, you can understand it. So first of all, let us see what is meant by this phi angle. We know the z-axis, we know r, the z-axis and the r is the radius. But what is meant by phi? Phi is the azimuthal angle, that is nothing but the curved surface we have, right? So it is having some angle. The range of this angle is 0 to 2 pi. 2 pi is nothing but 360 degrees. So degrees, what is the maximum range is 360 degrees and the minimum range is 0 degree. So as you can see here, so this is the cylinder. Cylinder is having some radius r, and this is the z-axis. This is the y, that is y, x, y, z. So in the Cartesian plane we have x, y, z. So in the cylindrical we have z, phi and r. So r is the radius, phi is the angle, z is the normal z-axis. So let us see what are the three cases. The three cases, what are the r is constant, phi is constant and z is constant. So let us see these animations so that you can understand them better. So the first one, here r is constant. Here we are having the radius r and we have cylinder. And the second one, so it is the second one. Here we are having some plane, right? So let us see this animation. So here phi is a constant plane and phi is the angle between the x and the y, or the plane x and y, sorry, x and plane. And the third one, the z plane which is moving upward and the downward. Hope you understand the three axes, the 3 points what we have discussed, 1, 2, 3. Those 3 points represent these 3 diagrams and their animations. So here we can see a diagram in which the three surfaces, what are the three surfaces which we have seen above here, that is r constant, phi constant and the z constant parts. Those are combined together so that there is a point P. Here we can see a point P where the three surfaces met. So this is the point P. When the three surfaces, so this is z constant surface, this is r constant surface and this is phi constant surface, this plane. So when these three are met, then there is a point P where the three surfaces have met, and here we can see a circle. So this circle is formed due to the intersection of the other two surfaces, and we have another two surfaces which form this line. This line is formed due to the intersection of the r constant plane, that is r constant, the diagram which we have seen above, and the phi constant one. When these two are joined, there is a formation of one line. So in the previously in the Cartesian plane we have represented how the unit vectors are present in the Cartesian plane. So in the same way, let us see how they are represented in the cylindrical plane. For example, this is a cylinder. Let us consider. It is a cylinder. So this is the radius and this is the unit vector AR bar or AR cap, that is a unit vector. And this is AZ bar in the Z direction and this is A5 bar. Or these three are unit vectors. And we can see that the distance between the P and this phi angle, the plane, this is a plane, right? So the plane length or the height is Z and the direction of this is AR bar. This direction is A5 bar, this direction is AZ bar. So these three are, what are they? They are unit vectors. This is a cylinder. If we consider it as a cylinder, then we can understand. So from this diagram, we can say that the P bar is equal to PR bar, which is nothing but the magnitude. This is unit vector which tells the direction. So PR is the radius of the arc and the P phi is the angle phi. PZ is the Z coordinate of the system. So this is the formula to find vector P bar. And if we want to find this, here we have phi. So when we are doing any differentiation or the integration, we should not consider the unit vectors AR bar and the A phi bar as constants, because here the AR bar and A phi bar are the functions of, so phi is a function of both the unit vectors AR bar and the A phi bar. So here phi is a function of both AR bar and the A phi bar. So these are the two unit vectors. So whenever we are doing any integration or the differentiation with respect to phi, d phi by dx, dx by d phi, something we are doing. So we should not consider these unit vectors AR bar and A phi bar as constants, because they are already a function of phi. Now the differential elements in cylindrical coordinate system. Let us see this diagram. So in the previously we have seen how if there is a small change in the element dx, dy, dz, how the coordinates are changed, how the position of the P is changed. So there we have seen in the Cartesian plane. So in the same way, let us see in the differential elements in cylindrical coordinate systems. So the changes will be the d phi, and what we have dr, and the other one is the dz. So these three will be changed, right? So but coming to here, in the Cartesian plane, all three are like, if you take they are in same dimensions. For example, if it is in centimeters, the x is in centimeters, y is in centimeters and the z is in centimeters. But if you take here in the cylinder, the top part is in radius, something like we can measure in meters or the centimeters. The bottom part also we can measure in centimeters or the meters, but if you take the curved surface we have to measure in degrees. But when we are taking when we are solving any problem, we have to make sure that the 3 units will be the 3 dimensions or the phi r z, the 3 should be in same dimensions, that means same should be in meters or centimeters. So what is the difference we have in the Cartesian and the coordinate system, cylindrical coordinate system, is the d phi. So d phi is having another dimension or the another units, that is in angles. So we have to convert the d phi into some length like dr and dz. So whatever the units we are taking here, whatever the units we are taking for the dr and the dz, the same units we have to take for the d phi. So in order to do that, so let us see here, there is a change in d phi, that is from z to here it has increased to z plus dz, and the other one is here phi angle is increased to phi plus d phi, and the other one is r r is increased to r plus dr. So these are the 3 changes have occurred in this diagram. If you see this animation you can understand it, or you can see this diagram. Let us see this diagram so you can better understand. Okay, next consider a point P. So here we are considering a point P. So this is P in a cylindrical coordinate system, and let each coordinate is increased by differential amount. So there is increment, so there is a differential change rate. What is the differential change? R phi z, they are changed to, r is changed to r plus dr, phi is changed to phi plus d phi, and the height is changed to z plus dz. So these are the 3 changes that have occurred. So I have told you before, in order to have the same units, we have to change the d phi value. So in order to change that, we have to convert into arc length. So d phi is converted into differential length. See this point. In phi direction, d phi is the change in the angle, but it is not change in the differential length. But if you take the z and the r, they are change in the length. But coming to the phi, it is not change in the length, it is change in some angle. Due to this change d phi, there exists a differential arc length in phi direction, and the differential length due to d phi in phi direction is r d phi. That is, here we have a formula, arc is equal to angle into radius. Arc is equal to angle into radius. So this is the arc length. So with this formula we can convert all the r, phi and the dz into same dimensions, same units, with the same units. So here the phi is converted into r d phi. From the formula, arc is equal to angle into radius. Radius is r and the angle is d phi. So now let us see. So d phi is the differential length in phi direction, dz is differential length in z direction, and dr is the differential length in the r direction. So what is the formula? In the previously we have seen dl bar is equal to dx ax cap plus dy ay cap plus dz az cap. In the same manner here also, in the cylindrical coordinate system also, dl bar is equal to dr ar cap or the ar bar unit vector r d phi. So actually here we have to write d phi, but in order to have the same dimensions, here we are writing r d phi. Okay, r d phi plus dz az bar. So this is the formula. One represents the magnitude and this unit vector represents the direction. And the other point is, in order to have the same dimensions like in the Cartesian plane, we have changed this phi into r d phi. So now in order to find the magnitude, we have to square the coefficients of the unit vectors, that is square root of dr square plus r d phi square plus dz square, and the volume will be What is the volume in the Cartesian plane? dx, dy and the dz. So in the same way, here we have d phi, dr and the dz. But in order to have the same dimensions, the d phi will be r d phi. So the volume formula is dv is equal to r dr d phi dz. So that is volume of differential elements. So as we have seen in the Cartesian plane also the three surfaces, here also we have to see how they are changed in different surfaces. So in the first one, AR will be the unit vector, and the second one A phi will be the unit vector, and the third one D phi will be the unit vector, but we will consider as R into D phi. So here it is also a cylinder like this. If you connect the dot lines, so it is also a cylindrical surface. So here DSR bar, differential vector surface area normal to the R direction. Normal means perpendicular to the R direction. And then this is the formula. And the d phi, in the d phi direction, dr, dz, d phi. And for this one, dsz bar, the formula is r d phi, dz and the dr. How we have to remember is nothing but, if we are finding ds bar r, if we are finding for r, then we have to write the other two differential change. Here we are taking the r, so we take the differential change of the other things. What are the other parameters? Phi and the z. Phi is represented as d phi, this is represented as dz, but d phi is represented as r d phi. So the formula will be r d phi dz, and the parameter what is there here we have r, right? So we have to write ar unit vector. In the same way, ds phi is equal to the other two parameters will be dr and the dz, and the unit vector is a phi. And the other one dsz bar is equal to, here we have dsz bar, so the unit vector will be dz bar, and the other two parameters are d phi and dr, and the unit vector is az bar, but we have to write for the d phi before r. So this is the formula. So ds phi is equal to differential vector surface area normal to phi direction, and dsz bar is differential vector surface area normal to z direction. So this is the cylindrical coordinate system. If you have any doubts regarding this, just comment in the comment section below. In the next video, let us see spherical coordinate system.